Okay. All right, so naming and writing acids is a little bit different than the molecular and ionic compounds we did before. Writing the formulas is going to be the same. You're still going to put the charges together like we did for ionic compounds. And what's the charge of a hydrogen? Plus one. Keep that in mind because we're going to be putting a hydrogen with something that's negative. And so we have to balance out the charges just like we did before. Okay. So if I'm putting it with a sulfate per se, which is a -2, how many hydrogens would I put with it to balance it out? 2. So it'd be H2SO4, which is in fact sulfuric acid. Okay. So writing the formulas is the same. You won't have a problem with that. The naming them is quite a bit different. Okay. The naming them is quite a bit different. The way that we're going to recognize acids when we see them, and we had that one worksheet that had 2, and I told you all to skip it. That very last worksheet we did, and I said skip those because we don't know how to get the formula from the name yet. There's 2 kinds of acids. There's an oxyacid and a binary, and we're going to talk about that in a second. Okay, writing the formula is going to be the same, but writing the names is going to be different. But the way you recognize an acid is it's going to start with a hydrogen, with the exception of water. Okay, water is not an acid, but it does start with hydrogen. But all your other acids are always going to start with the hydrogen when you see the formula. Okay. So, first thing we need to know is what kind of acid we have. Okay, first type is a binary acid, and that is it's hydrogen and one other thing. It's just hydrogen and one other thing, no oxygen. Okay, and when we have a binary acid, we're going to use the prefix hydro. Okay, and then whatever element it's with, we change its name to ic. So in this case, this is HCl, and it's going to be called hydrochloric acid. Okay. Hydrochloric acid. So if I had HBr, it would be hydrobromic acid. Okay, so those are fairly easy. Here's the thing I want to make sure: do not put hydro in everything. Okay, because that's what happens is people say, "Oh, it's an acid. I need hydro." You only use hydro when there is no oxygen present. Okay, and that's a binary acid. Okay, the second type of acid is called a oxyacid. Okay. What do you think that means it has in it?
Oxygen.
Oxygen, exactly. What it is it's going to be hydrogen bonded with one of the polyatomic ions. Okay, remember those things we had to memorize, like SO3, SO4, PO4, PO3. Those are going to all be, when they join with the hydrogen, they turn into an acid. Okay, now, here is the thing, and it's written on here for you, but I always have you write it so you can see it better. Whenever you're looking at a polyatomic ion, okay, if it ends in 8, right here. Oh, hold on, the ink's in white. That's not going to work today. What color do you want?
Blue.
Okay. It's not a very pretty blue.
Purple.
Okay. Okay. If it ends in 8, okay. Why isn't it working? There. If it ends in 8, right here, it's going to change to ic. Okay. So if I have this, in this case, this NO3 is nitrate, I change the ending to ic, and so it's nitric acid. Okay? If the ending of the anion ends in ite, it changes to us. So if I had NO2, HNO2, that would be nitrous acid. Okay? And if you have your pink sheet, which you're going to need, so get that out in a second. If you have your pink sheet, I encourage you on the bottom to write 8 to ic, ite to us. So when you're naming these, you can see that, okay, and you can remember it. 8 to ic, ite to us, okay? These are rules you're just going to have to memorize, okay? They're rules you're just going to have to memorize. All right, so let's look at some of the common roots, which I don't think are in your notes, so you can always refer back to this. Most of them are pretty self-explanatory. If you've got one of the halogens, it's just like it was when we were naming compounds, okay? The 2 that you have to be careful of is the sulfates and the phosphates. The sulfate, sulfite, because it's not sulfus, you have to put the sulfur back in there, so it's sulfuric acid. Or the phosphorus, for phosphate, you don't say phosphous acid or phosphic acid, you say phosphorus. So you got to put the R sound back in there for those. The rest of them are straightforward, okay? So if it's a carbonate, it becomes carbonic acid, like H2CO3, okay? So let's practice a few. All right, so we just did HNO2, okay? We know that the NO2 minus is nitrite, right? And let's write this over here, 8 to ick, ite to us. So if I have nitrite, what acid would that be? Ite, nitrous. So this would be nitrous acid, okay? HCl, I do not have oxygen, so I use hydro. So that's hydrochloric acid. And I encourage you just to memorize that formula because we will use hydrochloric acid a lot in our next unit, okay? H2SO4, SO4 is sulfate.
So it's hydros.
No, don't use hydro when you see oxygen.
Oh wait, there's oxygen, so it's
8.
sulfuric acid.
So it'd be sulfuric acid. Remember, that's the one we got to put the R sound back in there. So that'd be sulfuric acid. And you do have to write the word acid, okay? HBr,
Hydrobromic.
that'd be hydrobromic, okay? Okay. How about this one? This was a weird one. You won't see it that often, but how would I name that?
Hydronitrous? No.
Ick. On the hydro, they're always ick.
Ick.
Hydros are always ick. So this would be hydronitric.
So on every single one, hydro is always ick?
Yes, hydro's always ick. Okay. The only one that's going to have an us is an oxyacid. Okay. The only one that'll have an us is an oxyacid. Okay. And then this one right here, I don't think you have HF on your paper, so I'm going to skip that. But on your notes you have HI. It's the friendliest acid. Hi.
Aww, how sweet. You're so sweet.
This is this one's hard to say, hydroiodic acid. It looks funny. That's hydroiodic acid. Okay? And then H2S. Hydrosulfuric acid, yes. Okay? And the reason the naming is very important is because right here I have sulfuric acid, and down here I have hydrosulfuric acid. Two very different things. Okay? Sulfuric acid is very, very strong acid, and it is got a very, very low pH. Hydrosulfuric acid is not near as strong, and it's not near as common either. The oxyacid is a way more common. Yes?
Do we get to do a lab on these?
Do we get to do a lab on these? We get to do a lab where we use some acid,
Yes.
but we're going to be using very weak acid.
Aww.
Yeah, we'll be using very...
Not like metal.
Actually, yes. We're going to do a lab. I'm going to do that as a demo for you when it's actually right before I leave. We're going to put magnesium in hydrochloric acid.
What day are you leaving?
January 31st is my last day for a while. Okay, rules for writing the formulas. Like I said a while ago, writing the formulas you won't have any problem with unless you're still struggling with balancing charges. But if you can balance the charges, and most of you did very well on the test, then you can put these together. Okay, so this first one is phosphoric acid. We see that hydrogen, of course, is a +1. Phosphate is a -3, so it takes 3 hydrogen to go with 1 phosphorus. Okay? 3 hydrogen to go with 1 phosphate. All right, so let's practice some of these. Okay? Nitric acid. Here's the thing, we have to decide where it came from. Okay? So if it's nitric acid, oops, I'm doing the wrong thing. Ick came from...
Hydro.
No. Ick. There's no hydro there. It came from 8, so it came from nitrate. So it came from NO3 minus. So how would I write my acid? Just HNO3. Okay? Acetic acid, no hydro, so it's coming from a polyatomic. So it came from acetate, which is C2H3O2. So how many hydrogens would I put with it?
Wait.
It's got a -1 charge,
So one.
so just one. So I do HC2H3O2. Notice I put the H in the front. I just didn't add the H to that one that already had 3 in it. Okay, because when it breaks apart, it actually breaks apart like in a reaction right there. And the hydrogen goes its way and the acetate goes another way. Okay, carbonic acid, carbonate, which is CO3 minus 2. So what would it look like? H2CO3. See, I knew y'all would get the hang of this. All right, chloric acid.
Wait.
Chlorate.
Chlorate.
So find chlorate on your pink sheet.
It's ClO3, right?
Mm-hmm. With what charge?
-2.
No.
+2.
It's a
-3.
-1.
Oh yeah.
But you'd get there eventually.
Yeah.
Okay, so HClO3. Just need one.
Chlorus.
Chlorous acid is coming from chlorite, which is,
ClO2 negative.
okay, so again, I still just need one hydrogen. And then phosphorus acid is coming from,
Phosphate.
no,
Phosphate.
phosphite,
Which is
PO3 minus 3. So how many hydrogen do I need?
3.
3.
H2H3.
Okay. Now, I didn't really practice the hydrochloric acid and all that, but let's do a couple of those. Just because those are actually the hardest ones to name because of the us to ite and ate to ick. Okay, so I'm going to add an extra page in here. And so if I said write the formula for hydrobromic acid, how would I write that?
HBr.
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 Did you say HBr? Okay. How about if I did, let's give you a hard one. Hydrocyanic acid. Oh.
HCY.
You got that quick. Yeah, HCN. Because cyanide's a -1, hydrogen, so it would go like that. Okay? So that's where we're going to stop today. You have the worksheet that you picked up. That is due tomorrow. And then you also have your left side activities to practice. I know they're not hard, but I want you to practice the acids because as we go through, those are the ones that always trip people up, especially when we get to the types of reactions chapter. Okay? All right.